Divisibility tests. Quick tricks or divisibility tests that we can use to determine if a number can be divided by a smaller number. So, divisibility test 2. It can be divided by 2 when the last digit is even. So that means when it ends in 0, 2, 4, 6, or 8, right? Anytime it ends in those digits, that means it can be divided by 2. Now 3. It can be divided by 3 when the sum of the digits is divisible by 3. So if you look at 21, we break that into, right, the digits of 2 and 1, and we add those together. And we notice that it ends in 3, right? When we add those together, the product is 3. And so that can be divided by 3. So we know that 21 is divisible by 3. Now 5. It can be divided by 5 when the last digit is a 0 or 5. And then for numbers 7, 11, 13, 17, 19, we can just use long division. So let's go ahead and look at the first example. Example 1. Jack's gallbladder has collected a mass of 12 gallstones. Determine the prime numbers of gallstones that the mass can be divided by. So we're looking at 12. So we're going to notice that it ends in a 2. So 2 then, is it even? And the answer is, right, yes. So it can be, right, divided by 2. And so that's a prime number, right, that it can be divided by. Now 3. So we take, right, 12. We're going to go 1 plus 2 because we're taking the sum of the digits. So that's 3, which then can be divided by 3. So we know 12 can be divided by the prime number of 3. Now 5. Let's look at 5. Is it a 0 or a 5? The answer is no. So it can't be divided by 5. Then we can, right, go on to 7, right? Well, 12. Can it be divided by 7? The answer is no, because, right, it won't be an even number, right? Because it really needs to be 14 in order to be divided by 7, right? Right, that would be the closest number. So 7 doesn't work. 11 also doesn't work. And so we know that the prime numbers they can be divided by is then 2 and 3. Now let's go ahead and look at the next example. So example 2. We're going to look at a much larger number, 2,730. And what is it divisible, right? By which prime numbers? And that's what we're asking. And so we look at 2. We ask, is it even, right? That's the question. And the answer is yes, because it ends in a 0. So we can check mark this to say that it is divisible by 2. Now let's look at 3. So if we look at 2 plus 7 plus 3 plus 0, because we're looking at the sum of all the digits, 2 plus 7, 9 plus 3 is 12, right? Plus 0, still 12. And that can be divided by 3 because that would equal to 4. So we have a whole number that it comes out to be when you divide it by 3. So it's divisible by 3. Now let's look at 5. Now let's look at 5. Is it a 0 or a 5 at the end? Right? And the answer is yes. It ends in a 0. So it's divisible by 5. Now 7. We're going to have to use long division right now. Right? So if we do 7, 7 can go into 27 3 times. We subtract, we get 6, bring down the 3. Well, 7 can go into 63 9 times. We subtract, we get 0, bring down the 0. Well, 7 can go into 0 0 times. So we end with a, right, a whole number. It's not, there's no remainder. So we can go ahead and say 7 also works. Now let's look at 11. Now 11. So 11 11 can go into 27 2 times. We subtract. We get 5, bring down the 3. 11 can go 53 4 times. So that's 44. We subtract, we get 9. Bring down the 0. Well, we know 11 can't go into 90 evenly. So the answer is 11 does not work. Now let's go ahead and look at 13. Right, we just have to keep doing long division. Well, 13 can go into 27 2 times. We get 26. We subtract, we get 1. Bring down the 3. 13 can go to 13 1 time. We subtract, bring down the other 0. 13 going to 0 0 times. So we have a whole number. So we can say 13 also is a number that it can be divided by. So now let's go ahead and look at 17. Go right here. We subtract because it can go into 27 1 time. So we get 10. Bring down the 3. Well, 17 times 6. 7 times 6 is 42. Bring the 4 over. Then we have 102. So we have 102. We subtract, we get 1. Bring down the 0. This is supposed to be 6 right there. Well, 17 can't go into 10 evenly. So 17 does not work. So we can just go ahead and say our prime numbers then are 2, 3, 5, 7, and 13. So there's 5 prime numbers it can be divided by. So we could just stop right there.